Welcome to integration. Very important lesson. Pay utmost attention. Utmost. When we are given figures and there is a portion we are asked to get its area, it calls for deep analysis. You have to analyze that area and see if you can get it direct. If you can integrate, go ahead, get the final answer. If you cannot get it directly by direct single integration, this is where you have to pay attention. What does it call for? You look at that area, see which big area can I get first, which small area can I get next, then get the second area subtracted from the first big area to give you that region. So it needs a lot of analysis. Look at the figure now. We are given this figure. The area we want is here. This is the area we want, this. So this area here, we want it. What have you been given? You've been given the x-intercept and the y-intercept. What are they for? Once you see intercepts, they give you equation of a given line. The moment you see intercepts, and they will be very simple. Equation of a line from these two intercepts. You know the nature of lines. This has a negative gradient. And from change in y over change in x, it is 1. So the gradient is -1. The nature negative. The gradient here using this is 1. 7 minus 0 over 0 minus 7. -1. So my equation is y is equal to -x plus 7. There. That one can be gotten offered. In fact, I can give you B1. That is an offered thing. Once you see the intercepts, you get it straight. I come to my second point. Analyze the region before getting the final answer. I cannot get the answer to this area directly. No, it can't. So look, the first thing I do, I get this region, the whole of this. Okay? The whole of this. Look at this. From P to Q, come down. Come down. I've given it letter R. Go left. I've given it letter S. Go back up. It's a kind of trapezium. You can get it even using the formula for trapezium. But that would not help us. Education is about adding on top of your basics. So we are adding our knowledge. Which knowledge? I cannot get the area directly. What does that mean now? I analyze, see if I can come with two regions, after which you subtract and get the final answer. So my first is this, the whole of this. Then, now look at the curve, this curve. I have to get the area between this curve, x-axis, and the ordinates. The first one was the upper line, the x-axis and the two ordinates. Okay? So there is a portion. Check. There is a portion here. I'm going to put it in red. There is a portion here. You see? Now look at it nicely. The whole thing minus this part, you'll get the red one. Okay? That is what we are doing now. So what does it mean? Here, I have to get the limits. of my integration. This is the line. I want the area between the line, the x-axis, and the two ordinates. The two ordinates, this and that. Those are the ones which give me the limits. Okay? How do you get that? You get the limits, I've not done it here, by getting the point of intersection, this. Okay? The equation of the curve we were given as x, it is x minus 1 squared plus 4. That is the equation of the curve. The equation of the line, y is equal to x minus x plus 7. You are given the equation of the curve, and we found the equation of the line. So this point Q and point P are points of intersection. So please, how do we get points of intersection? I want to do it here because now you have known, I can work it there for you. So what are we doing? We are doing this. In short, if I may use a blue color here, this diagram, and then we have that. Okay? So if we get this, that is the area under the curve, and we have the whole area, then whatever I've not shaded is what they want. So let me rub here quickly, and then we get points of intersection. So note point of intersection. How do we get point of intersection? You make one letter the subject and then equate the two. Already here I have y as subject and y as subject there. So I have negative x plus 7 is equal to, here if you open, you will have x squared minus 2x and then plus 5. Where did I get 5? This will be plus 1 and then add to 4. It gives you 5. This is quadratic. You can solve it. You can solve this. In a nutshell, x squared, this comes this side. This minus x. This comes this side. Minus 2 is equal to 0. Okay? So the answer will be x minus 2, x minus 1 is 0. Let us counter check. Negative 2 plus 1, it is negative 1. Negative 2 times positive 1 is negative 2. So our x can be 2 and x can be negative 1. Okay, look at that. That means this is like 2 and this is like negative 1. I have the limits. Points of intersection. Points of intersection. If you are given two equations, make one letter the subject and then equate the remaining parts. Y was equal to this for the line. Y was equal to this for the curve. These two parts, you equate them, solve. Get the x values. If I wanted coordinates, very important, if I wanted coordinates, I take x in any of these equations. So this is the cheapest. I wouldn't go to this. Oh, you can't do that. X is 2. Put here. Negative 2 plus 5. Negative 2 plus 7. The y coordinate would be 5. Suppose x is negative 1. Negative 1. So it is 1 plus 7. 8, period. You can do that. The core thing I want you to get, area. Area. So how do I get this area? Area 1, as we said, is the area of trapezium. But I don't want to use the word trapezium. It's the area bounded by the line PQ, the x-axis, and the ordinates. The ordinates, the point R is 2, the point S is -1. And you see, this is the equation of the line. We integrate it with respect to x. Meaning what? Only the powers of x are affected. The process is carried out on letter x, period. Area 2. Again, I keep on modifying. What is area 2? In a nutshell, that. That is area 2. I want this area. Area bounded by the curve, the x-axis, the same boundaries. Look at that. Here. Remember, it is x minus 1 in bracket squared plus 4. So when you simplify this, it gives me x squared minus 2x plus 5. Where did 5 come from? In the bracket, I have a positive 1. Outside, I have a positive 4. You get that? So this is area 1. This is area 2. Okay? Now I want us to focus down. Again, I lower it a bit. Focus down now, here. Our focus is here. We finished with the interpretation of the diagram. So this shaded area will be area 1 minus area 2. Area 1 is this. Okay? Area 2 is this. Put first substitution. Be very careful now here. Be careful. First, it is 2. 2 squared is 4. 4 times negative a half, negative 2. I want us to focus. Sorry. I want us to focus. What did I say? Here. This is the integration. Now we are going to the process of substitution. 2 first. 4. Okay, so 4. 2 squared 4 times negative a half, negative 2. Correct? Here, 2 by 7, 14. First bracket, upper limit. Second bracket, lower limit. Negative 1 squared is positive 1 times negative a half is negative a half. Come here. Negative 1 times 7, negative 7. 2 brackets from the first area. We are going to the second area. 2 brackets. First substitution with the upper limit. 2 cubed 8 over 3. Come here. 2 squared 4. There. Come here. 2 by 5. 10. Remember, there will be 2 brackets. This is square brackets. These are curly brackets. There must be 2. And this is minus. Never put plus. It can't. Just like conjugate. If the first bracket is plus, the second bracket will have minus, and vice versa. Come here, negative 1, second bracket. Negative 1 cubed is negative 1. By a third is negative 1 over 3. Come here, negative 1 squared is positive 1, but there is minus there. Come here, negative 5. Now you have all this, which you can try. Could we again concentrate down a bit? Yes. I want us to get everything right up to the end. That is working. So you have this line. Now when you have that line, look, I don't need to cancel. No. You don't need to cancel. You don't need to cancel. Just see the way I handle it. How do I handle it? Look down here. This is negative 2. This is 14. Open bracket plus a half. Open bracket plus 7. The whole of this. Simple. I have 14 plus 7. 21. 21 minus 2. 19. 19 plus half, 19 and a half. Simple. Come here. We want to open bracket. Drop this the way they are. Minus, minus, plus, this and that, plus, this and that, plus. Check now. Check. 8 over 3 plus a third. That is 9 over 3, which is 3. I've finished with the fractions. I have a 3, a positive. So let us handle the positive. 3 and 5, 8. 8 and 1, 9. 9 and 10, 9 and 10, 19. 19 take away 4, 15. Here. 19 and a half minus 15. It gives me 4 and a half square units. Check. This work can easily be done. But what I want you to get here, I again rub because this part I didn't want it. How did I start as I conclude? The whole region. So check. The whole region. I took it like that. I got the whole region. The whole region. P, Q, R, S. I got the whole of that. After that, what did I do? I came and got the curve. That. I got that. Again, P, Q, R, S. Okay? So if I bring this one inside here, see, I'm bringing this one inside here. There, the blue. You see, it is only this part that has no double shading. Okay? So I took the big one minus blue, then without double shading is the answer. Okay? I'm sure you can do this again at home, slowly. Listen first, note key areas, try on your own. Bye-bye.